Hello, today we will be looking at graphing polynomials with a degree higher than 2. On the surface, it may seem complicated, but we will look at a few things that we can do to decrease the difficulty of the problem and help arrive at an answer. There are a few different methods on how to do this. However, in this video, we will be utilizing a sine table that will help us graph the polynomial. I do want to note that when using the sine table, you will not be able to find the peaks or valleys, how high they go or how low they go, but I can show you a trick or a method that will help you kind of determine the height of those peaks and valleys. When utilizing a sine table, it will be necessary to have a keen understanding of the various forms of factoring. If you need a refresher, I will link a few videos in the description below. Rather than going over any specific rules, let's just jump into a problem and work our way through it. The first problem we're going to look at is the function f of x equals x squared multiplied by x plus 2 multiplied by x minus 1 squared multiplied by x minus 2. As we can see, this problem is already factored. Again, we're just going to focus on a sine table. So what is a sine table? Well, the sine table will tell us where the graph intercepts on the x-axis. The sine table will help us understand the direction of the curve. With this, we need to find the zeros. How do we do that? We set the values. We set each factor equal to 0. So we get x squared equals 0. We get x plus 2 equals 0. We get x minus 1 equals 0. Because x minus 1 is a multiplicity of 2, we only need to do it once to understand where it's going to cross, and then we also have the x minus 2 equals 0. Solving for x, we get x equals 0, we get x equals negative 2, we get x equals 1, and we also get x equals a positive 2. Again, what this will tell us is where this crosses on our graph at the x-axis. So we know that it crosses at the origin. We know that it crosses at x equals negative 2. And we know it also crosses at x equals 1 and x equals 2. So these are the 4 points that it's going to cross the x-axis, and again we know this because we have factored, well in this case the problem has factored it down, and then we've just set each of these values equal to 0 to figure out what the x-intercept is. The sine table will tell us what the graph is going to look like on either side of either point. So it will tell us what the graph is going to look like on this side of the point. It's going to tell us what the graph looks like on this side of the point, and that's going to continue through each of the points that we have determined. Since we have our intercepts, we're going to make a number line, if you will. And that number line is just going to be our intercepts, and we have a negative 2, we have a 0, we have 1, and we have 2. Using the factors, we will be able to determine the overall sign of that curve before and after that point. We're going to make just a line here so that we don't get confused. And now what we want to do is list out our factors. So we have the x squared, we have the x plus 2, we have the x minus 1, but we need to show that that is a multiplicity of 2. So we have the x minus 1, and then we have the x minus 2. What we want to do now is we want to find the overall direction of the graph on values that are less than negative 2. If we want any value less than negative 2, all we need to do is select a value less than negative 2, and then we can plug that value into each one of these factors that we found to give us a sign. Once we get the sign of that factor, then we can multiply all the signs together from each of the factors to give us an overall sign, and that overall sign will tell us the direction the graph is going to go. We want a value that is less than -2. Let's just choose -3 because that's going to be simple. So we're going to plug -3 into the x squared, and so it's going to be -3 multiplied by -3. A negative times a negative is going to give us a positive. So for a -3, that makes that positive. We go to the x plus 2. We're going to substitute in -3. -3 plus 2 is going to be a negative value because it's going to be a -1. We have an x minus 1, so we're going to plug in -3 into that x minus 1. We get -3 minus 1 is going to be -4. That is a negative. X minus 1 again, it's going to be a negative because -3 minus 1 is a -4. And then our last factor that we have is x minus 2. If we plug in a -3, we are going to get -3 minus 2, which is a -5. Now that we found the sign for each of these factors for values less than -2, all we need to do is multiply these together to figure out what the overall sign is. By multiplying these signs together, we will be able to get the overall sign, and that means the overall direction of the graph. With that, we take this positive and we multiply it by this negative. That's going to be a negative value. That negative multiplied by that negative is going to be a positive value. That positive value multiplied by the negative is going to be a negative value, and then this negative multiplied by the final negative is going to be a positive value. So we know that to the left of -2, or all values smaller than -2, is going to go in a positive direction. Let's look at values between -2 and 0. Let's select a value of -1 because it's going to be simple. If we do -1, then we are going to do the exact same thing we just did, but instead of values less than 2, we're going to plug in -1. -1 into x squared, we're going to get a -1 times a -1 is going to be positive. A -1 in x plus 2, so it's going to be a -1 plus 2. That's going to also be positive. Then we're going to get a -1 into x minus 1, so a -1 minus a 1 is going to be negative. And we have that again because we have multiplicity of 2. And then our last factor that we have is x minus 2. So a -1 minus 2 is a -3, so that is also going to be a negative value. Next, what we need to do is multiply these signs together, which is going to determine the direction between the -2 and 0 intercepts. We take the positive multiplied by the positive, and that's going to be a positive. And then we're going to multiply the positive by the negative. That's going to be negative. A negative times a negative is a positive, and then a positive times a negative is a negative, which means our total overall sign is a negative. Okay, let's look at values between 0 and 1. In this case, let's choose 0.5 just because that's going to be between 0 and 1. And so if we use 0.5 into x squared, then what we're going to get is 0.5 times 0.5. It doesn't matter what the value is, it's 0.25. However, that is a positive value, so that's good. If we do 0.5 into x plus 2, that is going to be 0.5 plus 2, which is a positive value. We have x minus 1, and so if that's the case, we're going to do 0.5 minus 1. So 0.5 minus 1 is a -0.5. That is negative. We have the multiplicity, so it's going to be the same, but 0.5 minus 1, again, is another negative. And then if we have 0.5 minus 2, that is going to give us negative 1.5, which will also be a negative. So this is the exact same thing with what we just had. So we know that's going to be negative, but just so we can understand, we're going to take positive times positive, which is a positive. That positive multiplied by a negative is going to be a negative. Negative times a negative is a positive. And then a positive times it by a negative is going to be that negative. All right, looking at values between 1 and 2, let's choose 1.5. We're going to do the exact same thing. We're going to do 1.5 into x squared. That's going to be a positive value. 1.5 into x plus 2 is going to be a positive value. We have x minus 1, and so if we plug in 1.5 into that, we're going to get 1.5 minus 1. That's going to be a positive 0.5, so that will be positive. Multiplicity 2 is going to be positive, so 1.5 minus 1 is a 0.5. Again, that is positive. And then we have a 1.5 minus 2, and that is going to be a negative. In this case, we know that positive times a positive times a positive times a positive is going to be a positive, and then that multiplied by a negative is going to give us a negative value overall for that section of the graph. Again, what we did was we took this positive multiplied by a positive, and that gave us a positive. We took this overall positive, multiplied it by the next positive to give us a positive. That positive multiplied by a positive gives us a positive. And then positive times a negative is going to give us a negative, which is our sign there. The last thing we need to do is all values that are greater than 2. And so in this case, we're going to choose 3 because it's a value that's greater than 2, and we're going to do the exact same thing. We're going to plug 3 into our values to see what we get. 3 into x squared is going to give us 3 times 3, that's 9, that's positive. We do x plus 2, plug in a 3, it's going to be 3 plus 2, that's going to be a positive because that's 5. Then we do x minus 1, plug in a 3, that's 3 minus 1, that's going to be a 2, which is positive. We have the multiplicity, so it's going to be positive. Again, just the x minus 1. Substitute a 3 in there. We're going to get 3 minus 1, which is a positive because it's 2. And finally, we have the x minus 2. We're substituting the 3 in, so it's 3 minus 2. That's going to be 1, and that's going to be a positive. We know that a positive multiplied by itself 5 times is going to be a positive number, and that means this value is going to be positive. If we want to show this in steps, positive times a positive gives us a positive. This positive multiplied by the positive is going to give us a positive. We have this overall positive multiplied by our next positive is going to be positive. And then our last positive multiplied by our overall sign is going to be positive, which is what we have here. Now that we have our sign chart and we have the overall direction of where the graph is going to go, we are able to graph. And so we know, looking at values that are less than 2, we know that it's positive. If we know it's positive, it's going to be above the x-axis. Going between 2 and 0, we know is negative. We know it's going to be below the x-axis. Between 0 and 1, we also have negative. We also know that this is going to be below the x-axis. And then we have between 1 and 2, which is also negative. This is going to also be below the x-axis. And then finally, we have the value of 2, and anything greater than that, which is positive, is going to be above the x-axis. Well, as I said in the beginning, this doesn't tell you how low the peaks go. However, if you wanted to substitute in a value for these peaks, that would be able to tell you how far down you're going to go. So say you want to substitute in a -1, you would plug -1 into this equation. For example, if we wanted to find potentially the valley at its lowest point between 0 and -2, we can try a -1. So if we plug in f of -1, then that's going to be 1. A -1 plus 2 is a 1. And then we have -1 minus 1, which is -2 squared, which is 4. And then -1 minus 2 is -3. So we multiply those together, we get -12. So we know that this would actually go down 1, and that would actually put that about right here. And so if we wanted to, we could erase this and then make this go all the way down here. And similarly, you can do the same between 0 and 1, and you can do the same between 1 and 2. And then of course, if you want your graph to be pretty, you can, these connection points, you can make them curved so they look nice. And then you can also connect that a little bit better. But again, that's just cosmetics. What we're just trying to understand is the shape of this graph, and we're able to do that using the sine table. The graph looks something similar to this. As far as how low this valley goes here or this valley goes here, you would have to substitute in more numbers to identify how far down it goes. Okay, let's look at another example. We have the function x cubed plus 2x squared minus 4x minus 8. And the question asks to graph this function. What we need to do is similar to the last problem, is we need to be able to create a sine table. The only way to create a sine table is if we factor this problem down, so we have its factors, find the points where they intercept with the x-axis, and figure out the overall direction on either side of those intercepts. With that, we'll need to factor. If we factor by grouping, we should be able to come out with a few factors. In this case, we see that we have the x cubed and we also have the x squared. If we bring out an x squared, that's going to leave us with x squared x plus 2. And then we also have the -4x and the 8. And here, if we're factoring by grouping, then what we'll need to do is just factor out a 4. And that will leave us with an x plus 2 as well. And we see that we also have a common factor here. And so we can take that out. And if we take that out, then that's going to leave us with x plus 2 multiplied by x squared minus 4. We see that we're still left with this x squared minus 4, and we know that we can factor that by taking the positive and negative sign of the factors of 4. So if we take the x plus 2, that stays there, then we have the x plus 2, and we have x minus 2. Again, if we multiply that together, that's going to give us our x squared minus 4. And then if we have our x squared minus 4 and we multiply that by x plus 2, that's going to give us our x cubed plus 2x squared minus 4x minus 8. So that would tell us that these are our factors. Now that we have our factors, we're able to understand where they intercept on our graph. So we have, if we set x plus 2 equal to 0, we're going to set the x plus 2 equal to 0 and the x minus 2 equal to 0. So we know x is equal to a -2, x is equal to a -2, and x is also equal to 2. We know that it does not intercept at the origin. That means we are left with, again, a -2 and a 2. And this is where we're going to figure out what the graph is doing. Now that we understand that, we need to use our sine table to figure out the direction of the graph before and after our intercepts. Making our number line, we have -2 here, and we have a +2 here. Okay. Any value less than -2, let's use -3. And if we plug in -3 into our first factor of x plus 2, a -3 plus a 2 is going to give us a -1, so that's a negative. Since x plus 2 has a multiplicity, we know that's going to be the same. And then finally, we have our last term, x minus 2. If we substitute or plug in our -3 for x, it's going to be a -3 minus 2, which is a negative. If we do a negative times a negative, that's a positive. Positive times negative, our overall sign is going to be a negative. Again, looking at this, we have a negative times a negative. That is a positive, and then this positive times it by this negative gives us a negative, which is what we have here. All right, moving forward, we're going to choose any value between -2 and 2. And in this case, 0 is going to be our best bet because it's super simple. And so in this case, we have x plus 2. And when x is equal to 0, we have just 2. So that is going to be a positive value. X plus 2, plug in that 0. It's going to be a positive value because we're left with 2. And then x minus 2, plug in 0. That's going to be a -2, so that's negative. Now we have positive times positive, which is positive. Positive times a negative is a negative value. Looking to the right of 2, now we're going to choose any value that's greater than 2, so let's choose 3. If we choose 3 and use x plus 2, and we're substituting in the 3 for the x, then we're going to get 3 plus 2, and that's 5, and that's positive. If we take 3 plus 2 again for the second x plus 2, again, that's going to be positive. And then lastly, we have 3 minus 2, which is going to be 1, and that is also positive. So we know that a positive times a positive times a positive is going to give us a positive overall direction. Now that we understand the direction before and after each point, let's graph this. Again, this is -2, and again, this is 2. We know all points after -2 is a negative, so that means it goes below the x-axis. Now all points between -2 and 2 is also negative. So we know that the graph does something similar to this. And then lastly, we know any point that's after 2 is going to be in the positive direction because that's what we found here. So we know that that goes above the x-axis, and this is what the graph is going to resemble. Again, we don't know how far this peak goes or this valley. If you want it to, you can plug in values. For example, if we choose f of 0 and find out f of 0 here, we have -8, so we know that we can go down at least -8. But at the end of the day, we also don't know if that's the lowest. So if we go to 1, for example, and try f of 1, we're going to get -10, so that we know that actually if we go down even 2 more and we go over here, then that's probably going to be our lowest peak. And so if we want to, we can redraw this and go down to our lowest peak and then back up. And there you go. Now you understand how to graph a polynomial with a degree larger than 2 using a sine table to determine the overall direction of the graph before and after your x-intercept. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.